In column 1, we have different alkanes which are subjected to halogenation, and we need to match them with the various terms given in column 2. And one of them is some particular percentage of one particular isomer as product, another one given as whether two isomeric products are formed excluding stereoisomers, and whether any chiral center is generated or not. Let us do one by one. It is the first alkane, and that is subject to bromination. And we know that the reactivity of the primary, secondary and tertiary hydrogens towards bromination is 1 is to 82 is to 1600. So first here we are calculating the percentage of the various products formed. Here there are two different products possible because we can replace either the primary hydrogens or the secondary hydrogens. Let me consider that the product formed is X when we replace the primary hydrogen with the bromine. So I say the relative amount of X which is formed by the replacement of one of the primary hydrogen with bromine. So there are 6 primary hydrogens and the reactivity is 1. So the relative amount is equal to 6. Then the relative amount of Y which is formed by the replacement of one of these secondary hydrogens. And the number of secondary hydrogens are 4 and its relative reactivity is 82. And this becomes 328. So here the total amount, this becomes equal to 334. Therefore the percentage of X, that is equal to 6 upon 334 multiplied by 100, and that is equal to 1.8%. When this is 1.8%, definitely the second one, percentage of Y, is equal to 100 minus 1.8, and that is 98.2%. So one of the isomerase product to an extent of 98.2%. So definitely our answer should contain the point P of column 2. Let's check out whether this can form two isomeric products excluding stereoisomers. Definitely possible, isn't it? Because here we have primary hydrogens and secondary hydrogens. As only two different types of hydrogens are present, that is the reason why two isomeric products are possible. So our option should definitely contain even Q also. Then this bromination, can it generate a chiral center? Definitely yes. What is a chiral center? Whenever a carbon is attached to 4 different atoms or 4 different groups, that is called as chiral center. Take the case of replacement of secondary hydrogens. When any one of these hydrogens are replaced by bromine, that carbon becomes chiral. For example, it is Br, one hydrogen already present, and now I am writing this CH3, remaining one big group. So as this carbon is attached to 4 different groups, definitely this is chiral. So chiral center is generated. So the answer should be even R also. So correct match is P, Q as well as R. Let's see the next one. Here we have two different types of hydrogens. These are the primary hydrogens which are 9 in number, and this is one tertiary hydrogen which is 1 in number. And here the reactivity of the primary, secondary and tertiary hydrogens towards chlorination is 1 is to 3.8 is to 5. Same as that of the first example, we can find out the relative amount of the various products formed by the replacement of one of these hydrogens with chlorine. Let us say that the product formed by the replacement of any of the primary hydrogens as X. So the relative amount of X is equal to number of primary hydrogens 9 multiplied by 1, that is 9. Let me say that the product formed is Y when this tertiary hydrogen is replaced by chlorine. So now the relative amount of Y is equal to the one tertiary hydrogen multiplied by its reactivity, that is 5. So total amount becomes 14. So now the percentage of X is equal to 9 upon 14 into 100. That comes to be 64.2%, and the rest is 100 minus 64.5, and that is 35.8. So here it is very clearly given that one of the isomeric product is formed up to an extent of 64%. So definitely this is one of the correct matching. Let's see how many isomeric products are formed here. Definitely 2, isn't it? As 2 different types of hydrogens are there, so 2 isomeric products are formed. So this is also there in the final options. Now can this generate a chiral center? Definitely no, isn't it? Whenever you are replacing any one of the primary hydrogens, we will never get a chiral carbon. Again, if you are replacing the tertiary hydrogen with a chlorine, then also this carbon is not chiral because it is attached to 3 similar methyl groups. So here for structure B, the correct match is only Q and T. The same way you need to even calculate for the structures C as well as D. And in this case, there are again two different types of hydrogens. These are the primary hydrogens and these are the secondary hydrogens. And we are talking again about the chlorination here. So when you do the similar type of calculation, if I assume the product formed is X, when we are replacing any one of the primary hydrogen with chlorine, the percentage of X you get it as equal to 54.5%. For practice, I am not calculating here. And the percentage of Y is 45.5%. No such point is present in column 2. So definitely we cannot match that one. Then here again two different types of hydrogens are there. So two isomeric products are possible. Now tell me, is there any possibility of chiral center by replacing any one of these hydrogen with chlorine? Definitely no, isn't it? Because here both these carbons are attached to similar CH3 groups. So for this only the correct matching is Q. And here the last one. This is the alkane. Here we are subjecting to bromination. And here see, we have three different types of hydrogen. This is primary hydrogen. These are the primary hydrogens. Here the secondary hydrogens. And this is the tertiary hydrogen. So as three different types of hydrogens are there, definitely this cannot be our answer. And if you substitute any one of the secondary hydrogen with halogen, definitely we get a chiral center, isn't it? So that is the reason why this can generate a chiral center. Now we need to check out the percentage of the various isomers formed. Now let me write the relative amount of the isomer formed by the replacement of primary hydrogen as equal to 9 into 1, that is 9, because the product formed here I took it as X. Then the relative amount of the second compound formed Y, that is which is formed by the replacement of the secondary hydrogens, that is 4 into 82, that is 328, because we know the percentage, because we know the ratio of the reactivity of the primary, secondary and tertiary hydrogens towards bromination as 1 is to 82 is to 1600. Then similarly, when we replace the tertiary hydrogen with bromine, the product formed is Z and its relative amount is 1 into 1600, and we are getting the total amount as equal to 1937. So now on calculating, we get percentage of X as equal to 0.46, percentage of Y as equal to 17%. The remaining is nothing but the percentage of Z, that is 82.5%, and that is there. So this compound gives 82% of one particular isomer as product. So these two are the correct matching for the alkane D. So now what is the correct matching here? For A it is P, Q as well as R. For B it is Q and T. For C it is Q. For D it is R and S.